Good afternoon, everyone. Welcome to the virtual learning classroom of Al Afaq International School, Jeddah. Hi, grade 9 learners. Hope you all are doing great. Today we are going to learn geometry, lesson 12.2, Chords and Arcs. The instructions. Listen to the lesson's explanations. Open your geometry book, page 771, for the reference while explaining the lesson. Standards. From circle, recognize and apply the definitions and properties of a circle. Verify relationships associated with a circle. Objectives are to use congruent chords, arcs, and central angles. To use perpendicular bisectors to chords. Then we will do the classwork, which is from page 776 and 777. There are a lot of theorems which we are going to learn in this lesson. Theorem 12.4, it says, within a circle or in congruent circles, congruent central angles have congruent arcs. It means if angle AOB and angle COD has got the same measure, then the arc AB and the arc CD will be equal in measure. If angle AOB is congruent to angle COD, then its corresponding arcs, which are AB, will be congruent to CD. And the converse is, if the arc has got the same measures, okay, AB is congruent to CD, then its corresponding central angle, which is AOB, will be congruent to COD. Next theorem. Within a circle or in congruent circles, congruent central angles have congruent chords. Earlier we learned that the congruent central angles will have congruent arc measure. Now it's proved again that the central angles will have its corresponding chords also equal in measure. That is, if angle AOB is congruent to angle COD, then the arc AB will be congruent to arc CD. Now the converse is, if a chord CD or if a chord AB is congruent to CD, then its central angle AOB will be congruent to angle COD. Next theorem. Within a circle or in congruent circles, congruent chords have congruent arcs. Now within this circle, which is given over here, if the chord AB and the chord CD are equal in measure or they are congruent, then its corresponding arc AB will have the same measure of CD. That is, if AB, the chord AB is congruent to CD, then the arc AB is congruent to the arc CD. So the converse will be, if two arcs in a circle are congruent, then its corresponding chords will also be congruent to each other. That is, arc AB is congruent to CD, then the chord AB will be congruent to the chord CD. Next here. Within a circle or in congruent circles, chords equidistant from the center or centers are congruent. That is, if these two chords are equidistant from the center, then chord AB is congruent to chord CD. That is, if OE and OF has got the same measure, then the chord AB is congruent to chord CD. So the converse will be, if the chord AB is congruent to chord CD, then it will be equidistant from the center. That means the center to the chord, which is OE, is equal to OF. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Now here, AB is the diameter, and if it is bisecting, that is, if it is perpendicular, that is, AB is perpendicular to CD, then it will bisect the chord. It means it is cut into equal halves, and the corresponding arc also will be equal to each other. Okay, that is, if AB is a diameter that is perpendicular to the chord CD, then the chord will be bisected, that is, the chords will be bisected. So CE is equal to, the measure of CE is equal to ED, and the arc, corresponding arc CA is also equal to AD. In a circle, if a diameter bisects a chord, then it is perpendicular to the chord. That is, if any diameter which is bisecting the chord, then the diameter will be surely perpendicular to the chord. That is, if AB is a diameter and it is cutting CE, and that is, if it is cutting the chord CD into equal halves, that is, CE is equal in measure to ED, then AB, that is the diameter, will be surely perpendicular to the chord CD. I hope the theorems are clear. In a circle, the perpendicular bisector of a chord contains the center of the circle. If AB is a diameter and CE is equal to ED, CE is equal to ED, then AB will be perpendicular to the CD. That is the chord. If there is a diameter, AB will be perpendicular to CD. This was already told. Let's do one or two questions based on this lesson. Okay, in the textbook from question number 6 and 7, let's do question number 6. The circles are congruent. What can you conclude? That we have learned few things, that if the central angle is congruent, its chords are congruent and its arcs are congruent. So how do we write it? So the chords are congruent Yes, they are congruent, and its corresponding arc, that is corresponding arcs, are also congruent. So how do we write, how do we conclude it? That is, chord BC is congruent to chord YZ. At the same time, its arc BC is congruent to arc YZ. Question number 8. Find the value of x. Okay, it is shown that from the center to the chord, they are equidistant. And it is mentioned that half of the chord is 7. And so obviously the total of the chord will be 7 plus 7, which is 40, right? Now, when the chords are equidistant from the centers, then the two chords are equal to each other. So obviously, x is equal to 40. The theorem again states, once again, let's go back to the theorem, what we learned. That is, if two chords are equidistant from the center, then they are congruent to each other. Now, half of the chord is mentioned. So the length of one of the chords are 14. So obviously, the other chord is also equal to each other. So x will be 14. Now here, again, it is equidistant because they have given the congruency symbol. So this is also 3.5. So the chords are equidistant from the center, and again mention that the chords are, that is, cut into halves. So 1/2 is 5. So the total will be 10. So obviously, what is the value of this x? X will be 10, because if the chords are equidistant from the center, then the chords are congruent. So the one of the chords are 10. So obviously the other chord is also, will also measure the same, so which is 10. I hope it is clear. So we'll continue with the lesson later. Thank you very much for listening, and have a great day.